Black holes are the remnants of collapsed stars. They are regions of space so dense that they warp all around, distorting all before them. So much so that anything that dares to venture too close, even light, is unable to escape. Today, scientists are persistent in probing these hearts of darkness. And while no one is certain what lies hidden beyond their veil, current theories refer to a point of infinite density at the very center of every black hole, otherwise known as the singularity. Right about here is where the laws of physics, comprising space and time, totally break down. Nothing gets out, nothing makes sense, and there's nothing we can do about it. Besides black holes, though, there is another famous formative instance in the history of everything where a point of infinite density played a pivotal role, at the beginning of our universe. So could these events somehow be related to one another? According to some, they might be. In a black hole, the boundary dictating the point of no return is called the event horizon. In some ways, the event horizon can be thought of as a cloak hiding the singularity, only revealing it when it's far too late to turn back. What's key, though, is that as a star collapses to form a black hole, the event horizon grows rapidly outwards at first, and then more slowly as surrounding matter gradually falls into the abyss. It's a pattern that we've also seen, to some degree, at the start of the universe. The leading explanation on the birth of our universe is the Big Bang Theory. It says that everything began as an infinitely dense hot point, a singularity, which then expanded, much like a balloon, but at unimaginable speeds, before also slowing and transforming into the universe as we know it today, 13.8 billion years later. Of course, we know that the expansion has since accelerated again, likely thanks to dark energy, but that's for another video. The broad similarities between a black hole's evolution and that of our own universe's birth have, though, led some researchers to ask if our universe is the event horizon of another universe's black hole. Are we indeed living inside one of these most enigmatic and unknowable superstructures? The hypothesis is grounded in two central theories of physics: general relativity and quantum mechanics. General relativity, as formulated by Albert Einstein, is the macroscopic theory describing the universe at its largest scales, where gravity is a consequence of distorted space-time. Meanwhile, quantum mechanics deals with the world of the very small, beginning with atoms, before burying deeper and deeper into the fundamental structures of matter. Scientists have continually struggled to combine these two theories into something that best describes phenomenon where the large and small intersect, as they do so enigmatically within black holes. The Einstein-Cartan theory of gravity was one of the first, proposed in 1922 by the French mathematician Élie Cartan. It led scientists to look more closely at the quantum mechanical property known as spin, which then led to the development of a new concept known as torsion. Writing for Inside Science in 2012, the Polish theoretical physicist Nikodem Poplawski explains torsion as requiring a kind of reimagining of spacetime. We know that spacetime curves, but if we imagine it more as a thin rod rather than a wide plane, then via torsion, it also twists. And when this happens, all sorts of other weird stuff could also unfold. What's most important for today's question, though, is that torsion may have acted as a counterforce to gravity in the early stages of the universe, and it may do the same within all black holes. Poplawski proposes, as part of a 2014 paper, that torsional forces could mean that rather than a black hole being a site of infinite collapse, it could perhaps become a site of endless creation. It's a process that science now generally calls a big bounce. And we know that the wider Big Bounce theory is also one of the leading alternative theories on the creation of the universe. Broadly speaking, the Big Bounce theory argues that this universe, the one that we're all currently residing in, is actually just the latest in a long line of universes. They expand and contract in a regular way, and each time all of the matter and energy is redistributed, it produces something new. Even the seemingly unchangeable laws of nature, from our perspective, come out differently. But what could possibly facilitate such an incredible mechanism? What could house such a powerful process? You guessed it, a black hole. It may be enough to make you question the very ground you walk on and the very air you breathe. But what's even more exciting about this theory is that its implications are essentially endless. Because if we imagine for a moment that our universe does exist inside a black hole, then that black hole exists inside another universe. which could also exist inside another black hole, in another universe, and so on. It also suggests that every single black hole on our level, in our universe, could be a gateway to another world inside it as well. And considering that upper estimates predict that there are literally trillions of black holes out there, we have an essentially infinite supply of possible universe producers. And while we're unable to see and confirm what does or doesn't happen inside a black hole, observers from other universes would likely be just as oblivious, making it reality's best-kept secret. Importantly, there is currently no experimental evidence to fully verify this spectacular theory. It's just one of the many attempts to work out how, why, and where all of this started. But it does set the framework for yet another incredible approach, a grand-scale evolutionary process, as proposed by the American theoretical physicist Lee Smolin. In the early 1990s, Smolin put forward a theory known as cosmological natural selection. It not only suggests that black holes could work as though doorways to new universes, but that those universes are inherently shaped and perfected by whichever universe their black hole creator resides in. In such a reality, there are baby universes whose fundamental constants, the immovable rules that determine how they work, are shifted and mutated as they're passed down from their parent universe via a black hole. The long-term implications of this are that all supposed universes are gradually moving toward only the most effective and efficient versions of themselves. These are the ones filled with stars that could best become black holes that could then best birth more universes. You've heard it said that it's a dog-eat-dog world, but now it's universe-consume-universe. Again, though, cosmological natural selection is just one idea. And it can be suitably questioned, as modern science argues that information cannot be lost from a black hole, casting doubt over whether universe mutations could take place. But really, regardless, we can say that this question is more than just another zany what-if scenario. We don't know what's inside a black hole, and therefore have no real way of proving that we're not inside one ourselves. But if this really were how the universe came to be, then suddenly we're even more tiny than we had previously imagined. Earth is but one planet, in one star system, in one universe. We've heard that before, but now, that universe could also be but one of many in a spiraling, mesh-like web of infinite possibilities. It blows your mind a bit, doesn't it? But that